Hello and welcome to this tutorial on a set of pliers. So if we look at this assembly drawing, we have basically two of the main body components, and then we have a pin. The pin's 10 by whatever the thickness is here. And our pliers can open up 70 degrees and close fully. So we'll look at some advanced mates here as well. So go ahead and create the first part, a 10 millimeter diameter pin. Extrude it from the mid plane so that you have a pin and save that. That's pretty easy and straightforward. We'll go into our second part, which is the actual body of the pliers. So it looks like it's quite a complex part. A good choice for our origin, again, is always if it's the middle of a rotational point, that's fantastic. So we'll put our origin here. Looks like we have a thin portion in the middle of a unique shape. Then it thickens up. And then this is going on an angle and tapering inwards as well. So that looks like a good shape, good transition for a loft. Our actual handle portion, which is 14 millimeters thick, looks like it's starting from here, and it's actually sweeping this funky profile of like an arc and then another arc and a few lines. And then we have our gripping serrations on our actual jaws. So let's get going. We'll start off with the first bit of the body right around that hole. Okay, so we'll choose our top plane and go ahead and start a sketch. So we'll do our center circle, which is 10. We'll do our outer circle, which is 20. And then we'll basically draw the shape. And our shape looks something like this. Actually, I'm forgetting. Our shape looks more like this, of that center portion, where this portion is where the jaw is going to be out here, and then your handle's going to kind of come out here. So the first thing we'll dimension is this one, which is 12, right? So that's the height of that jaw, and because this point is horizontal, that means we're basically going to that center line if we make this a vertical line. So there's 2 dimensions missing from our drawing. So this one being 7 and the outside to inner being 40. So with those 2 extra dimensions, and we'll trim. So we're still underdefined because we don't know where this one is, and again, if there's we have to make an assumption that this point and the arc are vertical, and there we have our sketch. So we'll then go ahead and extrude, and our thickness is going to be 5, and we can go just a single direction this time. So next we'll add on this portion that starts the actual the jaw. So basically this rectangle here, and we'll add that rectangle we'll just do an extrude and get it in place, ready for our loft. So I'm going to sketch on that top plane again, and now we're going to put in a rectangle, and we'll do a corner. So we're starting from here and going down to the bottom. So we want to make sure we're snapped to that bottom. So the only dimension that we need in this one is, again, this one is not completely defined on our drawing. So it's very complicated to make drawings sometimes to get all those dimensions in, but this is going to be a 10, and then the thickness is actually on the drawing, and that's 10. So basically we've created this face that we're going to loft from. So this is the profile of that jaw that we're now going to loft. So in order for that loft, we need at least two profiles. So we'll convert our entities on this first face and create that first sketch. Then what we'll do is we want to actually create a plane. And so we know our plane based on our drawing is 70 from our right plane. So you can go 70 from that plane and create this plane. So now we'll sketch our end profile, so the end of our jaw. And so that is, again, another rectangle, and it's something like that. So this bottom edge and this edge are going to be exactly the same, and then our tip is basically 3 by 5, not 30, but 3, and this one is 5. And that's that. Those are the dimensions of that tip. And obviously, you can tell that it looks like it's tapering equally. So there's a couple of ways we can do that, but we already have this whole edge, and we have this midpoint. So if we select both of those and make those coincident, then that sketch goes right on the middle of our surface. So now we have our two sketches, and we can do a lofted base. So again, our starting points need to be at the same point, at the same corner, so that you don't get a twist. So now it's starting to look a lot more like that feature that I like, a pair of pliers. So now what we'll do is we'll actually choose, you have to make sure you choose a plane. If you're choosing the face, your cuts won't be actually parallel to this surface, because this is now an angled surface. So you always want to be sketching on those reference planes if you can. So go ahead and sketch in a circle. Sorry about that. So we'll sketch on the top plane, and we'll do a circle. So these are round cuts. So go ahead and put a 1 millimeter hole, extrude it through, and then pattern it however many times it says. It looks like it's about 12 or so. So for that linear pattern, and we select the cut, and because I chose through all on my cut, both ways, it cuts through everything. So that's those jaws. So now we're on to the tricky part of the handle. So it's going to be a sweep. And so the first thing you need to make for a sweep is a path. So we have a couple of items. So it's an arced handle, and typically always assume that the arcs are tangent. So we have a radius of 150, and we have this dimension from here to here of 110. So with that relationship on that endpoint and that arc of 150, we have a fully defined sketched. So that's the path of our. So now we're going to do our profile. So our profile, if we look at our drawing, this is going to be our profile. So we have this little undercut that kind of comes through there. We have our top part is rounded, and we can assume that these are concentric. Then we have a couple of flats that are 14, and that edge here is common. So let's go ahead and flip back and see if we can get that. So let's go ahead and select that face to sketch on. And now, so the first thing, we'll give it the general shape of a rectangle. So we know we're going to be from that corner to that corner, because that's how it's coming out. And then we know that it's going to be 14 wide. Okay, so now we'll come in and draw. We know our arcs are from here to here, and our other arc is from there to somewhere. So we'll add that dimension that's on the drawing. So it's a 6 diameter. So when we make these concentric, that will tighten this one up. So because it's constrained by the rectangle, so we don't need this as an actual line, and we'll get rid of our, and that gives us that shape. So again, those arcs are concentric, and that width is 14. So now we have a path and a profile, so we can select them and give it a sweep. And there's our handle. So we will notice one last thing on here, and that is this strange looking corner, so 5.2 by 60. So let's go ahead and go back, and we'll put in that chamfer. So if we choose our chamfer, so we want a distance and an angle, and you might have to flip that direction, and that looks like it's right, so it's going right into that corner, that 5.2. So, and it might not be the 60, so this one might actually be the 150 or 120 actually. Nope, it's the 60. So that's your angled. So now we have 2 of these saved, and we open up an assembly, and we want to insert our components. So the first one we'll fix this pin as our first one. Our origin of our assembly should be smack dab in the middle. So now we want to insert our other part. And we want first our concentric mate, which looks good. And we'll make these surfaces so that it's on. And instead of trying to mate, we want to actually mate this surface with the assembly plane. And we can make those parallel, or what we can do is we can come in here and we actually we're mating planes. So I'm mating the front plane of the assembly and the front plane of that body, and that's in there then. So now if we look, our part is fully defined. If you want to make a duplicate, holding down the control button while you select that part out of the feature tree, or you can go insert component. So we're going to mate those circles again, those shafts, and we'll actually bring it down a little so that they don't perfectly align. So mate them, and this time we're going to flip it. So, and then we'll mate those surfaces, get those nice. So this is good. We have a fully flexible. So we want to have actually two configurations. Again, we don't want to be selecting edges. We want to be selecting faces in our assembly. So this mate fully defines, and we can add a configuration that says this one is a closed mate. But what we want is we want to actually always have these to have a range. We don't ever want them to be here or here, because there's intersection. So we'll drive these two faces and we'll mate them. And then in advanced, so you can choose an angle. You can choose any angle that you want. So this allows me to just pick an angle, or we can go into advanced mates, and we have an angle mate, and we have basically a max and a minimum value. So our minimum value we want is 0, and our maximum is 120. And we'll click OK. So now what this has allowed me, 120 is not the right value. So if we look at the drawing, it actually says 70. So I actually want my maximum to be 70. And this is my current position. So I can leave it open a little bit. But so my min is 0 and my max is 70. So now when I'm actually in my assembly, I can have it open and closed, and it only opens up 70 degrees and it closes to 0. So that's the only range, and that's that limit angle assembly mate. So there you go. We have a nice pair of pliers, and you'll even notice that even though you can move it, it doesn't have that minus sign, because it's not fully defined per se, but it's defined so that there's enough information. So that is pliers for a workspace. So go ahead and save. Obviously, for your final workspace, you'll need to make some sort of adjustment, whether you're making them, put some wire cutters in here or something like that. But that is a loft and a sweep for that body, and then with this limit angle mate. Thanks for watching. Bye.